So I'm going to give you a brief introduction into L'Hopital's rule before we get into the examples. Okay, so I'm hoping that you read through the first part of the notes here, but I'll review it a little bit here. So L'Hopital's rule is a really powerful tool for computing difficult limits. Okay, so in particular, it's for calculating limits that look like this. Okay, so you might have a function f of x over g of x, right? Some fraction, you're trying to take its limit and you're trying to see what you get at the end, right? So one thing that we've run into is this situation of having certain indeterminate forms. Okay, so let me explain a little bit. So it might be that when you take this limit as x goes to a, so you'd be taking the limit of the top and then dividing by the limit of the bottom, right? So it's possible that when you take the limit of the top, you end up getting f of x going to 0. Okay, great. So then that means that the limit might be 0, right? So if the numerator on this fraction is going to 0, then maybe this number L is 0. Okay, but we're not sure about that, right? Okay, because you might also have that g of x goes to 0 as well, right? So if you think about it, when we're looking at something like this, if the denominator is going to 0, that means we're taking this. So sometimes this is a number, right? In this case, we don't really know. But if the denominator is going to 0, that means I'm taking something and dividing it by smaller and smaller numbers. And usually that means that the whole fraction is blowing up to positive infinity, right? So that's what that usually means. So it's possible that if g of x is going to 0, maybe L is positive infinity. Okay. So if we only had one of these two things happening, so if either f of x was going to 0 and maybe g of x was going somewhere else, like, I don't know, 5 or something like that, then the limit would be 0. Or maybe we have g of x going to 0, but f of x going to something else, right? Like -2 or something like that. Okay? In which case, the limit, the L, would be infinity, right? But something weird happens when both of these things happen at the same time, right? And you get this phenomenon where you don't really know if the limit should be 0 or the limit should be infinity. Okay, so that's where we get something called an indeterminate form, and the indeterminate form here is 0 over 0. Okay, and we've seen these pop up before, right? And usually when these come up, the thought is you don't really know anything and you have to do some work, right? So you have to do algebra or maybe multiplying by the conjugate or something like that, but you need to do something else in order to calculate this limit. Okay, so L'Hopital's rule is one of the things that you can do to try to find these limits, right? It's one of the more work things that you can do. Okay, so there's another indeterminate form that L'Hopital's rule applies to often, and that's the case when you have something like maybe f of x is going to infinity, right? So maybe the numerator is going to infinity. And then you might think, well, that means that the limit, so the fraction, should also go to infinity. Okay, but we're not exactly sure, so maybe g of x is also going to infinity. Okay, so maybe the denominator here is also going to infinity, in which case we're taking something and dividing by bigger and bigger numbers, and we've seen that that means that the limit goes to 0. But so once again, we're left with this idea that if both of these two things are happening, then should the limit be infinity or should it be 0, right? We don't really know. Okay, so it's very similar to the previous case with 0 over 0. Okay, so here again we get an indeterminate form, and this time this is infinity over infinity. Okay, and once again we don't really know how to do that, right, or what that means. Okay, so really what it means is that you need to do something else, right? You need to try something else. So L'Hopital's rule is one of those things that you can try. Okay, so L'Hopital's rule is essentially this, right? So this right here. Okay, so this is L'Hopital's rule, and it's saying that if you're trying to calculate a limit like this, right, so the limit of a fraction here, what you can do is instead calculate the limit of its derivatives, right? So take the derivative of the top, take the derivative of the bottom, and consider that fraction, and you can take the limit of that. And when you do that, you're going to get the same thing as if you'd taken the limit of the original fraction. Okay? So this is a really powerful tool, right? It makes it so that instead of calculating this limit, we can calculate this one. And often the limit of the derivatives is a little bit simpler to do, right? To calculate. So we'll see a bunch of examples where it actually makes things a little bit easier. Okay, so that's the next couple pages here.